Hello, Javin, can you hear me? Javin, can you hear me?
Yeah, hello.
Yes, hello, Javin, how are you?
Uh,
Javin, can you hear me?
yeah, I can hear you.
Okay, so how are you today? Are you
Uh, eh,
okay, Javin? Uh,
yes.
I so when I ask you, you say and then your voice disappear. So you are not feeling well today? You are sad? You cannot speak? Can you?
Uh, okay.
Hello, Javin.
Yeah, hello.
Yes, okay. So I'm not sure, is it your voice is disappearing or your mic is having problem or even my connection is having a problem. So part of
No,
your
I just said that I'm doing okay today.
yeah, okay. So I didn't hear that. Okay, now it's clear. Good. So
Okay.
Javin, what are you studying at your university at the moment?
Right now I'm studying computer science.
Okay.
Mm-hmm.
And okay, so you're studying computer science. What kind of subjects? Do you take programming, Java, Python? Uh, what do you study at the moment?
Oh, as of the moment, we are also taking programming languages like Java,
Okay. And
Python also. Yeah.
okay. So
Mhm.
okay, what about how is your progress in programming languages? Is
Going
it
okay.
is
I I
okay?
d- I do
Uh-huh.
understand. Mhm.
Okay. So do you take AI?
AI, no, not yet. I think
Okay.
it's this year.
Okay. So you study Python. So
Mm-hmm.
far, did you write what is the most complicated code that you ever write for Python?
Sorry.
What is the most complicated exercise
Mhm.
or project that you have done with Python?
Hmm. Hmm. For Python, complicated systems. Not sure because
Okay.
the last time I did Python was 2 years ago,
Oh,
first year.
okay. So so you are on the third year.
Yeah, this year I am third year. Yes.
Okay. So you have one more year and you can graduate. Am I right?
Somewhat one more half a year. Yes.
Okay, that's excellent. So you are progressing in a good way. That's okay. So you study databases?
Mhm.
Did you study?
Database.
Mhm.
We did, yes.
Okay. So did you write any code that you can retrieve things from a database and so on?
Mhm. Sorry.
So did you write any coding project where you are able to retrieve data or even save data to a
Oh,
database?
oh, that, but I think I'm not that great in database.
Okay. So, okay.
Mhm.
Just don't feel tension. Actually, this just a discussion so that I'm able to understand where you are at the moment. And so again, I'm
Okay,
not an examiner. I am just
okay,
here to help as much as I can to simplify your subject. So the subject that you are studying at the moment, a little bit makes sense when you are studying AI in depth.
mm-hmm.
Um,
Okay,
Only in certain topics in AI, um, the
mm-hmm.
language related topics in AI. So, like maybe similar to like ChatGPT and so on. So they try to make sense of um, um, how to say English words and they translate it
Mm-hmm.
to mathematical formulas to make sense of it, because at the end, the computer is a dumb thing. If you don't write code to make it work or understand something, then the computer at the end of the day does not really understand the English characters or even sentences. So they need to come up with things where computer is a master. Computer is a master when you tell him there is a relation between A and B. So there the computer is can excel more than the human. He can make can recognize and figure out things when you tell him, oh, find a relation between this and this. Okay, so at the end, text and English words does not really make sense of him unless we start to analyze that and try to find relations, and not or, exclusive or, and so on. Okay, so maybe if you don't really go in depth of AI, maybe this subject will be only just to pass it in the exam, and then maybe you will never experience it in your projects. So even if you work with AI, like a visual recognition, so you try to recognize maybe part of an image, if it is for a human or not, using an AI and Python. So maybe you will never experience it mathematical discrete mathematics. Okay, so this is only related when you're talking about languages. So let me give you let me start with a little bit introduction. This is typically with every student that I got. This will only just warm us up. Okay, so this is just like how I say. Okay, so this is like it's a little bit tips and tricks on your ways of studying. So that will only last for maybe 20 minutes or less than that, and then we will try to move on our subject. So okay, did you hear before about brain chunks?
Not quite familiar, I would say.
Okay, so brain chunks is actually when you are trying to learn a new subject, and then you're trying to digest the new information that is given to you on the new subject. So I would say that the brain cannot really grab or understand information in a big chunks. So if you try to memorize a phone number that is in this format, and there is a lot of numbers here, so your brain find it difficult to digest that. So it works best if you try to divide that phone number into small chunks. Okay, and not only that.
Okay.
So okay, actually, is it my voice is like lagging, or you are not hearing it in a clear way?
No, it's clear for me.
Okay, that's great. So the point here that when we divide this phone number into small chunks, and then we try to say, okay, the 9 and 5 and 4 can represent what in your brain? So maybe the 9 represents September, and September is the birthday for maybe some of your relatives. And maybe 5 is can maybe represent May, and May is actually maybe something memorizable. And you are able to memorize in your brain, but maybe you say that, oh, this is my exam dates. Okay, so you can memorize it. Or you can tie the new information to something that your brain already knows. So by doing so, by tying the new information to the old information or something that you know for sure, actually can make the new information stick to your brain. Okay, so that is what we say memory chunking. So we use this simple example of a phone number, but actually we are able to apply the same concept to every topic that we're trying to understand. So when we divide the topic into small pieces, then and we try to find relationships between this information and to something we have in the brain, that will actually simplify the information and make it memorizable in our brain. First of all, I just want to tell you that typically the brain will not make the information stick unless you try to engage with the information. It means that anything that you read passively will not really stick to your brain. So the information that you want to study really will start to stick when you take notes, summarize key points in your own words, or even discuss the information that you studied or learned with others. So this is considered an example of engaging with information. Also, another thing that you need to note when you're studying a new topic is that you try to find relationships and patterns and connections between different pieces of information that you're trying to learn. So that help your brain to actually start to engage with the information, and not only that, it make it stick in the long-term memory. Okay. Did you understand anything from what I said so far?
So far, yes. It's okay.
Are you able to tell me anything from what you understood?
It's like taking in information bit by bit so that our brain can or it's better for our brain to understand some sort of like that.
Okay, excellent. Okay, so okay,
Okay.
that is actually excellent. Just let me try to tell you, when you are trying to memorize or study a subject, your brain does not really benefit from rereading the subject. So if you want to say that, oh, I want to study this subject and more, just rereading the same topic again and again does not really help you, and does not really tell the brain that this is an important information that you should not forget it. There is something called practice retrieval, which means that if you study a subject and you want to tell your brain this is important, you close the book and then you start to retrieve what you actually studied by writing it on a paper. So this is what we say practice retrieval. So by doing so, the information will really start to stick to your brain and you will start to remember it. So when I try to ask you, actually, I'm not stressing you. I'm helping you to stress your brain and do this kind of practice retrieval. So I am not testing you. I am not here to tell you are good or bad, because even if you are bad, I still need to help you. So it doesn't matter. This does not really matter to us here. So again, I am stressing your brain, not you personally. So
Okay.
so don't feel stressed when I ask you questions. Okay. So it is just a practice for your brain. And so this is from the neuroscience perspective. Okay, I am not going to reveal to you or even explain to you everything about neuroscience or everything related to the brain. I'm just picking certain topics that I find that my student really benefit from it. Okay, so
Okay.
that is one thing. Second thing is that there is a small thing that I would like to highlight to you. If you want to study a subject, practice spaced repetition. Spaced repetition means that if you want to study this Python, for example, I would not say that you study it 3 or 4 hours a day in one certain day in a week. I would say divide the 3 or 4 hours that you dedicate for Python during the whole week. So I would say, if you say I want to study 4 hours of Python, don't do it in one day. So just do it in one whole week. It means that you divide maybe one and a half hour, 1/4 an hour, maybe if every day, if it is possible to you. That is a practice that is called spaced repetition. So when you do that, you actually starting to strengthen the links inside your brain that is related to the topic that you are studying. So that actually benefit a lot. So this and this, if you always do them with any subject, it will help you a lot. You are
I see.
So because that also serve another technique, which is what we call interleaving. So if you are, if you would say that you have 4 hours for Pythons, another 2 hours for Java, and maybe like say 3 hours for databases, okay? So, and you want to actually put this in one whole day, another whole day, another whole day. So I would not recommend that, because the best thing for your brain is to mix. So we call this interleaving. So you take 1.5 hours for Python, another 1.5 hours for Java, maybe another 1 hour for databases. So when you do that in one whole day, that is best for your brain. So your brain start to find relations internally, not by you thinking. So internally, he will start to make relations between Python and Java and databases. At the end, they are still related. Although they are slightly different topics, but the brain likes it when he start to build relations between things. And also, again, that will deepen your understanding for all the 3 topics. And again, relations is what is the key for making information stick to our brain. Okay, is that clear so far?
Okay. Yeah, so it's clear. Yeah.
Okay, so okay, do you recognize what you are seeing on the screen? Did you ever use a book index before?
Index. I don't know. Never. I usually skip that.
Okay, so okay, if you are trying to buy a book about certain subject, and you want to know if they really discuss or mention these certain topics in the book, you are not going to search. You are not a computer. I mean, yes, most of the time, if you have a PDF copy, you are able to just search the whole book using the certain keywords that you want to find, and it's very easy. But if you are in a bookstore, so that is very hard. You need to really refer to a book index to be able to know if a certain words is mentioned in the book and in which page that topic is actually mentioned. So that is the purpose of a book index. So why I'm telling you about a book index? I just want to relate that to your brain. Your brain have actually something called a memory index. So that is why I show you this book index. So what is important for us here, when I'm explaining about memory index, there is 2 parts in your brain that's called hippocampus. That is a memory index. That is responsible for archiving and organizing the information in your permanent memory. But how can you make use of that? So the main thing that I'm explaining this part to you is that the hippocampus is a place that have a limited capacity. It gets saturated every 15 minutes in adults. So saturated means it cannot really take more information. So imagine that your hippocampus is like a cup of water. So you keep pouring out water to that cup until the water starts to flow out. So it means that your cup cannot really accept more input. So if the hippocampus cannot accept more input from your working memory, this is a problem, meaning that information will start to get lost, and that is not good for you. So typically teachers who know that, who study that, they will make a 1 or 2 minutes of silence every 15 minutes. That will help the hippocampus to actually empty their place to accept more new information. So the hippocampus actually act as a middleman between the working memory. So every human has this, okay? So every human have a working memory, and they have something called long-term memory. And this long-term memory actually is a slow learner. it does not learn very fast. At the moment when you are listening to me, the one that is really active, it is your working memory. But the working memory is a temporary memory. It forgets things very fast. If I give you information now and ask you about it in 10 minutes, it will disappear. It's not because it's bad or it's not malfunctioning. This is how it works. That's why we have a middleman. The middleman takes the information from the working memory and try to store it in the permanent memory. But because the permanent memory is a slow learner, so we need somebody to keep repeating the information from him. So the one who will help in this repeating is the hippocampus. So it organizes the information, this hippocampus, organize and make indexes and make links for information in the permanent memory, and make sure that the permanent memory learns the information that you have at the working memory at the moment. Every adult can only grab 4 pieces of information in his working memory at a time. So certain people are fast learners. So they might have, maybe can catch or can keep 3 pieces of information at the same time. And there is a slow learners who can hold 3 pieces or even 2 pieces. So if you are a slow learner, it does not mean that you are bad or you cannot even reach the same level of expertise like the fast learner who are able to learn or hold 6 pieces at the same time. But it does mean that this guy will reach fast. You will reach slow, but you will have some other benefits. This is, I mean, in this class, we will no need to discuss that. But what I want to say that working memory have capacities. That's why you find somebody who are having a math problem, he's able to solve it very fast, and other can take some time, but can reach the same destination at the end, or can reach the same solution at the end. Again, what I want, the takeaway from this slide is actually one thing. If you're studying alone or watching a video related to your subject, and I want you to give your brain 1 or 2 minutes of silence every 15 minutes. This is the takeaway from this slide. Is it okay? Did you understand what I want to tell you from this slide? Are you confused?
No, I understand.
Okay, because I only hear silence, so I hear like that, and then I'm not sure. So did you get lost from me?
No, I did.
Aha, and now I start to recognize your words is cut from the middle, and only now I can recognize that. So it means that it certainly means that I am not always grabbing your answers. So I will need to confirm that always, please, that I get your answers. Okay. Because yeah, just now only I see that your words was cut in the middle. So okay, let me see that. So do you face any problems when you are studying that you feel that you understand things or you solve problems in a slow way compared to others? Do you feel that?
Solving
exercises
sometimes I can, sometimes I do solve in a slow way, sometimes.
Okay.
I guess.
Okay, no problem. So, okay, so again, just what I wanted to say, also another takeaway, I just want to tell you that there is a professors who are also slow learners. And so,
okay.
And there is a programmers, I've worked in the programming environment a lot before. So there is a programmers who also are slow learners, and which mean that it is okay to be a slow learner. Just make sure that the quality of the thing that you do can compensate for the long time you take to actually produce some code, for example. Okay. Now let us focus again so that we can move on to our topic.
Okay.
Again, this is. Did you ever see something like that before?
This, no, I don't think I've seen this before.
Okay, so this is how your information in your brain looks like. We call that this part, when there is a lot of links between different information, we call that information consolidation in the memory, or sometimes we say short memory consolidation. This memory, so imagine that you learn something, things start to link together in your brain after some time. It does not happen immediately, but it happened during your sleep. So having a good sleep is very important. That's one thing. So this memory consolidation sometimes happen in weeks and sometimes in months. So a good memory sleep every night is okay and is good. And I also want to tell you, even if you are a computer science major, it really helps and it really helps your brain abilities and the ability to solve problems faster and in a creative manner if you actually read in a lot of topics, even if it is not related to your computer science or to your major. So assume that you want to become a Python programmer. It does not really harm you. Actually, in reality, it benefits you if you study subjects like discrete mathematics, even though it is not directly related. So the more subjects that you actually study, that enlighten your brain and make your brain very good in making connections and trying to find relationships between different things. Okay. So in short, the takeaway from this slide: have a good memory sleep, because that helps your brain to consolidate the information that you study. That is one thing. Second thing is that the more time that you keep studying, even if you don't really fully understand things, it will make sure that maybe after a few weeks or maybe 1 month or 2 months, the information will get consolidated in your brain and you will find improvement in actually your way of thinking or your way of solving exercises. So don't think that just because you didn't understand something or you didn't solve one exercise one time, then you will never be able to solve it. Your brain improve over time. That is in short. Okay. Did you manage to understand what I say? Okay. So far, okay?
Yes.
Okay,
yeah,
that's
okay.
good. So this is the last thing that we're going to talk about brain. So there is one mode of thinking that your brain actually able to achieve, but not everybody know how to actually trigger that mode. So at the moment when you're listening to me or even solving an exercise, your brain function in something called a focus mode. Okay. And there is something important, other mode, there is one more other mode that is important, which is diffuse thinking mode. So it is important in your exams, and it is important when you are trying to find solution for difficult exercises, especially if it is related to mathematics or even a coding one. Okay. So to trigger that mode, you have to make your brain or your body totally relax, which means that you think about nothing. When you think about nothing, you are actually triggering the diffuse thinking mode. So when do we need to trigger the diffuse thinking mode? We need to trigger it in the exam, and we need to trigger it when we are facing a problem that our current focus mode are not able to solve. Imagine that you are trying to solve a problem in Python, and you don't really know what code to write to solve that problem. So if you're stuck for half an hour, I would say just leave what you are doing and try to relax stop what you're doing totally, try to relax 1 or 2 minutes, 10 minutes, go to maybe one of the things that triggers the diffusing mode is to go to a shower, take a shower, go by the sea, go walk by the sea, go look into some greenery scenes that will also help your mood to relax, but just don't think about anything. That will trigger your diffuse thinking mode. So I personally, when I'm stuck with the code, I say that I don't want to give up. And then I try to keep finding solution, but I stuck for hours. So before I know that trick, I never practiced it. But when I practice it, I then just like maybe 1 or 2 times of this triggering for diffuse thinking mode, I'm able to solve the problem in a very short period. So I advise you to do that. And in your exam, you're able to actually trigger the diffuse thinking mode by going through all the exam questions before you start to solve any of them. And then start to mark the difficult questions. Okay, so definitely there will be tricky questions that need your attention. So you read that difficult question and attempt, so you read them all one shot. Okay, I mean, you go through all the exam question one shot, and then you mark the difficult exam questions, and then you start to attempt to solve one difficult exam question, and then you stop once you are stuck and leave that difficult exam question, and then you move to another easy question and start to solve. When you do that, you actually triggering the diffuse thinking mode, and you are actually making use about part of your brain that actually can work simultaneously while you are actually focusing and solving the easy questions. So did you study about dual processor before, or even hear about it?
Sorry?
Did you ever hear or study about dual processor?
Dual. I don't think I'm also familiar with that.
So, okay, did you ever study how the processor inside the computer works?
Yes, ever.
Okay, what about multiple cores? Did you hear about multiple cores before?
In terms of computers,
Yes, in terms of computers. Did you
yes.
ever study? Okay, so
Yes.
yes, okay. So multiple cores, they make it so actually work on executing 2 instructions at the same time, just to speed up how the computer is executing instructions. So when you do this kind of thing, which is triggering the diffuse thinking mode in your exam, you are actually making one part of your brain act as if it is the second core. So one core, you will be solving easy questions. Another core will work in the background and try to find solution where you got stuck in actually the difficult question. So this is how we say that your brain now function like a dual core or a multiple core processor. Okay, so this is a trick that I'm going to say to here, and then we will end up this portion and we will move on. So, okay, typically, I'm not sure if it is related in your case, but for students who have where I'm giving them their own slides or the slides. So for every student, I got a URL dedicated to him. And typically we have the class summary mentioned for every class. And if we are doing video recording for the class, then they will find a link for the video recording also in one of the sections in the dedicated URL. So for every student have a specific URL that here can use to actually access all the class resources. Typically, this kind of class resources is only available after 36 hours of the class, because I need to get help of some of the assistants to do that. They upload, they convert the videos and upload it to YouTube, so that you got the links here. And typically, what I want to say that the slides or even the exercises are actually stored on Google Drive. So you find the links in the URL, and from the URL, it will take you to the Google slide. So I believe that is in short. Of course, you are able to find titles for every video that is recorded, and also the description of those on the YouTube. So that make our job a bit easier, because it's a bit hard to upload videos into Google Drive, and of course it occupy a huge amount of space that we are not able to accommodate all the videos for all the students. So that is in short. So of course you are not taking Python or any programming language with me, so there is no relation to creating a Replit account and so on. But then I will move to your slides. But let me know.
Okay.
Let me know here. I wanted to ask you about something, but I forgot. Yeah, I got one Python code that was passed to me, but I didn't have a chance to check it yet. I think that was from your mother, but I wasn't sure. I wasn't very sure. What is it for? So you need to,
Python and
yeah. But never mind. Uh-huh, uh-huh.
that code was from another assignment. I think I accidentally put it in the folder.
Okay. But it's not related,
Yeah.
right?
Uh,
Is it related to the subject that we are studying?
no, it's not related. It's not related.
Okay. Okay. So, okay. Of course, we have to go. So, let me just tell you this. So, we will go through small sections at a time, but we will do a lot of practice. So, it means that during the
Okay.
class, we will try to solve as much exercises as we can, because that also give me indications on what I need to improve on the next classes. So I mean, if I don't know where you are, then I'm not able to offer you a helping hand. So typically, if I keep repeating to you the theoretical part, and then you go home and stuck with solving exercises, this does not really make a big sense for a tutor. So okay, so that is how we're going to do it. So we will take small
Okay.
sections from here, and then we will
Okay.
go solve exercises. Not only that, I find it actually
Okay.
this slide is a bit,
Hmm.
to me, a bit strange, because they are jumping from different topic very fast without making a good transition. Okay, that's
Hmm.
why I have to sometimes I find not enough information about certain topics here, so I try to use I try to create some helping slides that might simplify the topic a little bit. And just to be frank, this professor that is giving you the subject, I
Hmm.
don't think that
Yes.
he is very honest, because he is giving you, I mean, the books that he's giving you
Hmm.
is far. First of all, it's not simple, and it's not the best book for the subject. And I know that he's getting his content from different other books. Okay, of course that took from some time from me to be able to really understand from where he's copying that different things. But anyhow, we will try our best. It doesn't help that we talk
Okay.
about him. Let's focus on the most important thing here. So
Okay.
okay, uh, I will try to do recall. So what do you see? I mean, what is the proposition, or what is the statement in from what you can remember?
This is truth. Um, it's like of, if I'm not mistaken, in this chapter.
Okay, so so again, I start to worry that the voice is not very clear. So you told me it is tough. Is that this is what I almost hear?
No, basically this chapter is it's about like true and false, kind of.
Okay. Okay, true and false. Okay. So, okay, I
Yeah.
think I have to keep this on here to be able to see when your voice stops. Okay. Okay. Yeah. Okay. So what we want to say that a proposition is it can be we can say that a certain statement is a proposition if it can have a value of true or false. Okay. So but not both. So any statement that we cannot give it a true and false, then it is not a proposition. So if we say 1 plus 1 equal 2, so this is what we call is a statement or a proposition because it can have, I mean, the equal sign here give us a chance to say that this is true or false. So if you say 3 plus 1 in this case, this is not a statement or not a proposition because we cannot say 3 plus 1 is actually true or false. I mean, it is not a statement where you are able to judge it's true or false. Again, it's missing an equal sign to something, so we are not able to compare the result to something, so we are not able to say it is true or false. 2 plus 2 equals 3. It is a proposition because we are able to say it is true or false. In this case, it is false. It doesn't matter. It is still a proposition. So if we say Toronto is the capital city of Canada, why is it a proposition? Because we are able to judge and say, or even to judge the statement and tell if it is true and false. Washington D.C. is the capital city of USA because we have a chance to say to actually validate the statement and tell if it is true and false. So this is what we call a proposition. Again, when you say go away, this is not a proposition because we cannot validate this statement and say it is true or false. Go away is an instruction, but it is not a proposition. Did I make it clear to you?
Yes, it's clear.
Okay. So again, in your slides, your professor referred to true or false sometimes as a T, sometimes as a 1. And he referred to false as F and 0. So this is in short, and then let us move to the next here. Okay. So actually statements, they got 2 types of them. So what we refer to a statement, so like the previous slide, this is a statement, but this is a primitive statement. A primitive means that we cannot break it more than that. So this is its basic format, okay? And if we would like to actually make a more complex statement, so we have to combine 2 primitive statements together. So a compound statement can use any of those tools that we will learn about, okay, to actually combine multiple primitive statements to make it a compound statement. So may I know, what did you understand now about a compound statement?
It's okay, for this one, all I understand was like, how to explain this?
No worries about making
like,
a perfect English. It's okay. I mean, if you make mistakes, I will try to digest, but I still need to understand if my explanation is actually reaching you in a proper way. So I am testing myself, not you. So don't worry about your English. Just say whatever come to your mind.
Okay. Well, something like with like example, there's like and it's an indication of if both is like something like that, and it's the same thing for uh or because or indicates whether one is true or yeah, either one is true but not both, something like that. uh
Okay. Okay. So,
mhm.
okay. Can you see here? So
And it's
this,
basically
mhm. Yeah, 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 say,
it's also uh like an implication. It's implying something, so something like that, I guess.
okay. So,
Hmm.
we
Hmm.
say uh, Javin is a student. So this alone, we consider it
Hmm.
a primitive statement. And if I want to
Hmm.
make a compound statement, so I'm using the and here, and I put it in the sentence, and then I add
Hmm.
another primitive statement. So combining these two primitive statements will give me a compound statement. So I'm using here that this kind of tools that is giving to me negation, conjunction, and or XOR, and implications and by conditional. So
Yes.
okay, may I know which of those seems hard for you to actually understand? From I'm talking about this
Okay.
here.
Okay. I think the one that disjunction exclusive.
Okay, XOR. Did you study? Did you
Yeah, XOR.
study? Okay, so did you study logic gates?
Sorry.
Did you study logic gates?
Oh, logic. Yeah, I did.
Okay, that's good. And and so far you're able to really hear all my words, or is it cut in the middle, or is it broken word?
So far, so far, yes.
Okay, okay, that's good. So so okay, um, let me just okay, let me go through all of them. So you still
Mm-hmm.
remember that this refers to the end, and this
Mm-hmm.
sign refers to the or. So the or
Yes,
say that, yeah.
mhm. Yeah, I still remember. Yeah.
Okay. So exclusive or actually means either one is true, but not both. So okay, we will see
Mm-hmm.
that from the from this truth table. Let us have a look at the truth table, and we will see that. Um, okay. What about implication? What did you know about implication? Javin, are you speaking?
Mm-hmm. Yeah, sorry, my internet is kind of unstable.
Okay. So, did you talk about anything? Did you reply
Okay.
me? What did,
Sorry, my internet is kind of unstable.
okay, no problem. So what I want to say that what do you know
Kinda.
about
Yeah.
what do you
I
know?
mean, I'm at home. Mhm.
Okay, what do you know about implication?
What do I know about implication? Mm, it's it's like something implies something in a way.
Okay, did you
Like,
remember what ways
mm-hmm.
we try to actually indicate an implication? So, did you remember the format that we use for implication, which is if then? Do you remember that?
Implication. Yeah, something like that. If
Okay.
it's like this, then it's like that, something like that.
So if it is not raining outside, then I'll go for a walk,
Mm.
something like that. Okay. So okay. We
Yeah.
also, for implications, we use two keywords: sufficient and necessary. So what I will say, let me have a look at the next slide. Okay. And let me, yeah, I think, yeah, it's better to go to the next slide, and then I will take you into helper slides where we are able actually to see more examples. So if you see any of these forms, so this actually refer to implication. So if you see P implies Q, this is an implication, and this is referred by this here. And also another
Mm-hmm.
form of it is if P then Q, if P Q, and when P Q, all of those actually are referring to implication. So I would say that you actually maybe need to really memorize all of those, and we will talk about necessary and sufficient in details now. Okay. And the point here that if they ask you if a statement, if an English sentence is actually an implication
Mm-hmm.
or reflect an implication or not, the only way for you to know that, if you already memorize this and start to figure it out in the English sentence. So if you only remember if then, and then they bring for you something different, like when or whenever, like this, then or because or since, then you will not be able to know or recognize that this is an implication, because sometimes he give you a question and then he asks you to actually make mathematical representation of an English sentence. Okay, so this is very important actually for you to memorize. Let me try to go through the next slide, and after this, I will take you to helper slides. Let me try to go here. So as you can see, he's still using English, like I told you. This subject at the end,
Mm-hmm.
it is a way to make not us understand the English, but to make the computer actually make sense of different sentences, especially if it is a compound sentence or a complex sentence that have and in between. So they need to represent that mathematically. So we have P representing I passed the exam. So this is a primitive statement. And we have R is representing I hate discrete mathematics. Q represent I attend classes. S represent I love discrete mathematics. So if he want to use the negation, which is the not, so he will pass the not. I mean, some books refer to the not as a dash like that, but okay, since your professor is using here this way, so we still follow it. So at the
Mm-hmm.
end, if you want to say
Right.
to add the not to this, I did not pass the exam. So you still have to adjust a bit. So definitely you cannot say I not passed the exam, because it doesn't make sense. It doesn't follow the English grammar.
Mm.
So you need to still adjust it a bit to make it.
True. Yes.
Sorry again. Did you hear me correctly? I heard some word, but I didn't recognize it from you. Can you repeat that
Mm.
again, please? Can you
Uh.
come?
I don't. No, I don't. I think I didn't say anything. Sorry.
Okay, no problem. It's okay, no problem. So at the end, you add not to the P.
Yes.
Okay, actually, there is anybody else in with you in the room?
No. No one.
You
No,
oh
I'm
you
alone.
are oh okay, okay. I saw somebody else speaking. Yeah, no problem. It's okay. So
Okay.
So if we add not to the P, like I said, I would say I didn't pass. So we have to modify this passed and we add did not pass to make it understandable in English. So if I want to add not to the Q, so how should I put it? Should I say I not attend classes? Is it correct?
I did not attend classes.
Excellent.
No.
Okay. Yes.
I think it's okay.
I didn't attend classes is correct. So adding just the not alone will not make it a proper English statement. Okay. So we need to make it in a proper way so that it's understandable. Okay. Now, if I would like to combine the Q and the P with an and. So have a look here. I passed the exam. I attend classes. So if we want to add the and in between them, so I just get this Q first. Here, I attend classes and I passed the exam. Is that difficult to understand?
Yeah, it makes sense.
It makes sense. Okay. So, okay. Now, if we add not to the Q, and then we want to tie it to also B, so notice here we will not use and, we will use but. Okay. So that and but actually exactly like and. Okay. So typically sometimes he will give you a sentence like that, and he will ask you to make the symbolic representation for it. Okay. So again, he is adding not the negation to the Q. So I did not attend classes, but I passed the exam. You cannot say, and I passed the exam. Okay. So is that clear?
Okay.
When you say,
yes,
when you add the not here, you use but. Is that clear so far?
Yes, it's clear.
Okay. So good. So let us move to here, the or. So we're going to connect the R and the B with or. So I hate mathematics, or I passed the exam. Definitely, this does not really make much sense, but he's giving you an example of how to connect two primitive statements using an or. So let's have a look at the XOR. So the XOR here, again, he will connect P and Q with an XOR. So I hate discrete mathematics, or I love discrete mathematics. So I mean, does this make sense when he connects them this way?
I guess so.
But wait, he actually, there is a mistake here. So the mistake is that actually, if you look at the P and Q here.
Okay. Yes.
Okay. The P and Q, I passed the exam, I attend classes. But what he used here, actually, he does not use P and Q. He used actually R and S. Am I right? So this R and S.
Yeah.
Actually,
you're right.
Yeah. So I'm not sure it's a mistake or it's by intention, but to me it's a mistake lah. Okay. So what I want to say that so
I mean, actually,
I'm listening. You said actually, and then I didn't hear anything.
Oh, actually, not. Yeah, because not. Yeah, like you said, it's not sure if it's a mistake or not, because this is actually not his slides.
It's not the slides of the professor, is it? I mean,
yeah, it's not his slides. It's another lecturer slide.
Oh, okay.
He
But
used another
he's
one.
using them.
I mean, yeah.
Okay. So
yeah, he's using.
Okay. So this is what you're going to study, right?
Yes.
Okay. So definitely, okay. We have to stick to that. So what I want to say that you cannot have in your heart two feelings at the same time. You either will hate or love
Mm.
discrete mathematics. You cannot have both at the same time, right? So, I
Yeah.
mean, if we look at the or here, so this is a topic, and this is a totally different statement. And he's not talking about the same thing when he's using the normal or. But the exclusive or is actually what we can say that either one is true, but not both, because you cannot hate and love the same thing at the same time. But here, inclusive, it means that you're able to hate it, but you still able to pass the exam, or I pass the exam. So one of them can be true, or even both can be true at the same time. But in this case, you cannot hate and love discrete mathematics at the same time. So, and that is why what we call exclusive or, but I will give you more examples to deepen your understanding of XOR. But so far, is it clear?
So far, yes, it's clear.
Okay. So again, let us have a look at the implication that we looked at before. He's using the simple form of it.
Mm.
So we have if and then. When we saw them, then definitely this is an implication. So the P here is a hypothesis. So, and the Q is the conclusion. So definitely if the hypothesis does not happen, then the conclusion also will not happen. And we will see that in details in the helping slides. So if I love discrete mathematics, then I will attend classes. So maybe if I don't love it, definitely I will not attend the classes. So it's important is that you're making let me explain this hypothesis in the helper slides. I have other helper slides. So let us continue here with the biconditional. So the biconditional is actually it's marked by if and only if. So when you see that, then this is a biconditional. So Q biconditional S, this and this. So I attend classes if and only if I love mathematics. Okay. So we will see on the next slides also what is the how we can relate the biconditional with the implication. But so far, is everything clear so far in this slide?
I would say so far it's clear.
Okay. That is actually good. Okay, let me move to the helper slides, please, and then. Okay. Okay, so can you read this, please?
Oh, okay. Um, when you make a
I mean, here.
logical inference or deduction, you reason from a that one. Okay, sorry. If 4,686 is divisible by 6, then 4,086 is divisible by 3.
Okay, so what he's saying here, if we reason from hypothesis to a conclusion, so if such and such is known, then something or other must be the case. So if the hypothesis is okay, if it's the case, or if it is true, definitely then we will come to the conclusion that is always also true. So a sentence form if P then Q is actually also, yeah, I think we already explained that here. So, but does this make sense to you? If something is divisible by 6,
Yeah.
then it is divisible by 3. You know why?
Because
So,
Because
okay. So what I want to say that if this number is divisible by 6, so definitely it will be also divisible by its components, which is, or its factors, which is 2 and 3. So if this is true, definitely we will come to the conclusion that this number is also divisible by 3. Okay. So that is
okay.
why we say that this is a conclusion. Now, I want to share with you here. Suppose this is actually an example of an implication. So this says, if you show up on Monday morning, then you will get the job. Okay. But
Okay.
so if you go to interview for a job at the store and the owner of the store makes you a promise, then he will tell you that. So, but then what is the circumstance that we can say that this is actually going to be false? It's a false statement, or he speaks falsely. So that will be false only if you show up on Monday and you do not get the job. So when this implication will become false is when you show up on Monday and you don't get the job. So we will say that this is false. Of course, that will be only clear from a truth table.
Okay.
So if you look at the truth table, you will find that the only condition for the implication to actually become false is when the P, which is the hypothesis, is true, but the conclusion is false. So it means that the implication result will be actually false. So we will say that this is false. It's a false implication only when the hypothesis is true and the conclusion is false. So when did this occur? If you go to the work on Monday, but you don't get the job. Is that clear to you? Is that clear when we can say the only condition that can make
clear.
Hypothesis or the implication here a false? This is how it looks like. Hypothesis is true, conclusion is false, and other than that, we can memorize that all the other condition is actually true. It doesn't matter here; it's true and true, false and true, false and false. It doesn't matter. The result will be true except when this condition happen, when the hypothesis is true and the conclusion is false. Okay, so far okay?
Yeah, it's okay.
Okay, so good. And let me see here. Can you look at this, please, and maybe try to read it and tell me if you really understand anything of it?
Consistent. If 0 is 1, then 1 is 2. 0 is 1, then 1 is 2. This one suddenly get it a little bit.
Okay, so is it 0 equal 1? Is that true or false?
Is
this alone, forget about the whole thing, just only this.
Okay.
If we say this statement is true or false, is 0 equal 1? Is it true or false? Don't be afraid.
It's false.
Excellent. So this is false, okay? And is that 1 equal 2 or no? True or false?
It's false.
Okay. And we have seen from the truth table in the previous slide that if we have false for the hypothesis and the conclusion also is false, so this is the hypothesis and this is the conclusion. And if you have false and false, the implication can still be true. So the statement is as a whole is true. But both the hypothesis and the conclusion is actually false. So what I want to say that he is telling you, if it happens, if it ever happened, that the 0 is equal 1, so then it is also possible that the 1 is equal 2. It will never happen. It will never happen that the 0 is going to be equal 1. So it is also not going to be happening that the 1 is equal 2. So in any situation where you can ever find 0 equal 1, then you can imagine that it can also be possible that the 1 is equal 2. It is impossible that this will become true. And that's why also it is impossible that this will become true. So what I want to say that this proves the truth table. So based on the truth table, you will find that when the hypothesis is false and also the conclusion is false, the whole statement still be true, because both of them is actually false. Does this make sense, or is still confusing?
Now it makes sense. Yes.
Okay, but
now it makes sense. Yeah.
Okay, so what I want to emphasize again that of course maybe there is nothing on the slides that deepen the explanation of this, and even in the book. And to be frank, even in your book also, they don't really deepen the understanding of why every item in the truth table is actually makes sense. Okay, so but I just want you to remember this too here about this example of getting the job if you go on Monday to the work, and also about the 0 here. So if we say here, this is a hypothesis, this is a conclusion, here equal 0 equal 1, and here 1 equal 2. So if you try to remember that, I believe definitely that will this truth table will start to really make sense a bit more. Okay. Okay.
Okay.
What I want to say here, so this is talking about the biconditional. Let me try to. Okay. So again, this is just as simple as biconditional. This is explanation for it. If and only if takes place. So let me go to an example because we already. Okay, so I would say let us try to rewrite this statement using the if-then format in two ways, one of which should be using contrapositive. I believe we did not study yet about the contrapositive, but never mind. John will break the world records for a mile, for the mile run, only if he runs the mile in under 4 minutes. So again, this is the statement. So we can refer to it as a P, and this is the only if that refers to the biconditional, and this refers to the Q. And so if we want to write actually this biconditional in the form of if then, there is two different ways. I think this is slightly more easier. So if you see it here, can you please read it and tell me if you really understand anything from it?
Okay. If John does not run the mile in under 4 minutes, then he will not break the world's record. Okay. Well, I understand that if he fails to run the mile under 4 minutes, then he can't break the world record.
Yes, but just bear in mind, when he converts the biconditional, he converted into this one way. He brings the Q first. So it means that he puts the Q, he negates the Q, okay? and then he
Okay.
implies, because we are using if then, right? So this is the if, and this is the then, and this was our Q here, and this was our P. So he will also say, he will negate the P. So it means that if he is, so it means, it simply means if P biconditional Q, like that, it should be equivalent to not Q implies not B.
P.
Okay, and
Okay.
so okay, what we also want to say, we will go into deep understanding of this in when we try to prove actually this using the truth table. So just
Okay.
be patient with me here. Another way to actually make this rewriting is to actually use, if John breaks the world record, if he breaks the world record, then he will have run a mile in under 4 minutes. So this is another way to actually rewrite this statement in an if-then. So I believe this also need a kind of memorization from you. So this kind of thing, when you only try to memorize statements in this way, maybe it will not really make much sense to you. But when you memorize it with an example like that, so typically it will stick to your brain a bit better than only looking at the statements like that. Okay, so far, does it make sense?
Okay.
Are you able to grab what we are saying at the moment? Even if you are not understanding 100%, if you understand more than 60%, it is enough as a start, because the more we practice and the more we see more slides, things will become a little bit more clear. Did you understand more than 60%?
I would say yes, I do understand.
Okay, I believe you didn't exceed 70%, right? Understanding.
I I guess almost 70%.
Okay, that's okay. Yeah, that's okay. So let me try to. So in short, what we was trying to do at the moment when we talk about John and breaking the world record. So if we have a biconditional statement like that, we are able to write it in two ways. We are able to say not Q, so we bring whatever here first, and we negate it, and we say the then not P, so we also negate the P in this way. So, so this is one way to write this biconditional statement. And there is another way to just write if B, then Q. Okay. Let me try to tell you here.
Okay.
If we have statements, we need to actually understand order of operations. And I believe if you ever studied arithmetic operations in Python or even any programming language like Java, they will tell you if you got this arithmetic operation, maybe let's assume that you say int a equal maybe how to say 5 plus 3, and then you say multiplication for with 10, so and maybe divided by 5 or something like that. So they will tell you the where you actually start to resolve. So they will tell you that this brackets is having high precedence, so it needs to be executed first, and then they will tell you that the multiplication and the division have a high precedence than the plus and minus. So that is what we are trying to do here. We're trying to let you know the order of operations. So you need to negate things first. After you do the negation, then you try to evaluate the and the or. And the last thing that you need to evaluate is the implication and the biconditional. So far, is it clear, this? Is that clear?
Yeah. Yeah, it's clear.
Okay. So I will say, so if you have, so this is the truth table. Let us have a look at it, please. And I would say, so this is the implication. And so this is P and Q. Typically, when we write a truth table, so the first two for the first item that we list here, which is the P in this case, it can be R, S, or whatsoever. It doesn't matter. It's all the same. But what I want to say that we write, when we are displaying a truth table, we write the two true first, and then we follow that by two false. Okay. And the second one here, if you notice, we write true and false and another true and false.
Okay.
Okay. So if you notice that, and then if the truth table is more than 4 items, now it's only 4. Why? Because we have only 2, we can say like variables. Let's say it's variables or 2 things that we actually need to prove here. So we say 2 to the power of 2 give us 4. That's why we only have 4 rows here. Okay. So if we have maybe 3 variables, like we have an R, then we have to put 2 to the power of 3, which means that we need to have 8 rows. Okay. And then we will look when we have 8 rows, how we are going to actually write this so that we don't have to memorize it. Okay. So far, okay?
Yes.
Okay. Do you recognize that when we say P implies Q, this could be the result? And so we know that when we say P implies Q, actually, the result will be always true except one thing. When actually we look at the Q, we find false, and we look at the P, we find true. Only then this will result in false. And we can still remember John condition. No, not John condition, but the condition where or the statement where we said, if you go to the job Monday, and you will get the job. So if we still remember that example, then we will stick, it will stick to our mind that this is the only condition where P implies Q will become actually false. Other than that, we write all true. Q implies B. Can you tell me why here this is F, this is false?
Because Q is T. If you rearrange it, it's like Q is T, P is F, like that.
Yes, excellent. Right. Okay, it's good. Yeah, I understand that you understand it. It's okay. That's good. Okay, so now if we have a look at the P biconditional Q, so we will actually recognize that the truth table is that we can start to memorize it when both P and Q have the same condition, which is true. If both of them is true or both of them is false, we will actually have a true and true. Other than that, if both of them is different, then we will have false. And this is actually the inverse or the opposite of what? Can you tell me? This truth table is opposite of what?
Negate Q implies P. Oh.
If you can remember the XOR, so the XOR will tell you false, true, true, false. So this is exactly the opposite of the XOR truth table. So biconditional is totally opposite of XOR. The thing that I want to say to you that it helps you to find relation. So if I would try to memorize something, I will not memorize the XOR and the biconditional, two of them. I will memorize one and try to figure out that what is the relation between the XOR and the biconditional. So if I memorize that, then I will know, I will just put it in my mind, I will try to learn that XOR is opposite the biconditional. And from here, I list that and I make it opposite. So if I want to make this an opposite, so I will make here true and true, and then I make the opposite like that. So this is how you come up with this truth table of the biconditional for only from the XOR. Is that clear so far?
Yes.
Okay. So if we look here, so this guy is actually trying to find if this biconditional is actually equivalent, okay? And your professor always referred to the equivalent with this sign, okay? So he used double lines like that with both arrows. He referred to it as biconditional, but in the books, many times they use this sign. But actually, both of them is actually the same, okay? So he's trying to see if this side is actually logically equivalent to that. And one of the ways to actually prove that is to use a truth table. So if you look here, he say P implies Q and Q implies P, and then he put AND in the middle. That's why he make both truth tables for both sides here, and he tried to AND them. So if he AND them, do you remember what is the condition for the AND? When we're going to have a false on the end?
The condition of AND, something and something.
Okay, let me.
Sorry, can you repeat your question?
So, okay, my question to you is that, no problem, it's okay, no worries. So what I want to say to you here that I wanted you to tell me what is the conditions that will make this AND result having false here. So now we're trying to this is two statements. So what will make the result end up having false here?
P implied Q is false while Q implied P is true. So it implies that it's false.
So okay, that's so it means that the AND in the end, if we ever have false in the truth table, it will result into false. Is that right? Can we say that the AND
for an operation, yes.
Okay. Are we able to say that the AND is like a multiplication by 0? If you ever so if the false is represented by 0 and you multiply it by 1, definitely the result is going to be 0. So it means that if you ever have false, then the result will definitely be false. Is that true, what I'm saying?
Yes.
Okay, that's good. Okay, so if you look at these two, actually, do you think that from the truth table, are they equivalent? Do you think they are equivalent?
Yes.
Based on the truth tables, they are
yes,
equivalent, right? Okay, excellent.
Yes.
Excellent. Okay, this will be the last thing that we discussed today. So that is actually part, sometimes part of even the questions that come when it is in things related to implies. So when we say P implies Q, it sometimes the English sentence might actually contain sufficient condition and necessary condition. Actually, it is mentioned in your slides, but there is no clarification about it in the slides. That's why I needed to come up with this slide. So look at this, please. So this is actually using sufficient condition. So Pia purse on U.S. soil is a sufficient condition for her to be a U.S. citizen. Okay, sufficient condition. So how can we rewrite that in the if-then form? This actually is implies. How I know that? It's just simple. I can share with you again these slides.
Mhm.
So this is your slide, and your slide here implies or say that this sufficient and necessary actually is indicating implication or implies. Okay, what else? Where is it also mentioned? P is a sufficient for Q. It means P implies Q. P is a necessary for Q. It means Q implies P. So these two is actually part of your slide, but it is not explained into details. So that's why I needed to create a helper slide for that, so that you know that we are still sticking to your slide. Actually, so your slides actually does not really take whole chapters. It just pick a little bit topics from here and there and then put it on the slide. But anyhow, so Pia, if she is born in U.S. soil, then she can be a U.S. citizen. So if Pia was born on U.S. soil, then she is a U.S. citizen. So it means that we are able to actually remove that and try to tie this P and Q to make it in a form of if and then, so that it is a clear way to understand that P implies Q. So if P, this is the if, and then standard one for P implies Q, and we just need to modify this English grammar a little bit. So if Pia was born on U.S. soil, then she is a U.S. citizen. So far, is that understandable or confusing?
It's understandable, yeah.
Okay. Let us have a look at the last slide here. So what I want to say that this is another example, but oh, sorry, yeah, that is about contrapositive, but I want to make it on the next time. I just want to only discuss about sufficient and necessary. So I would like you to see this example about necessary. So the necessary here, it's also telling that P implies Q, or even R implies S. So, but the necessary have to be in not R and not S. So this is how, when you see necessary and you want to convert it to if then, so you need to write it in this way. So George attaining age 35 is a necessary condition for his being a president of the United States. So if he is attaining 35, then he is able to become the president of the United States. So one version that we can use is that we need to use the not R. So if George has not attained age of 35, then. So of course, this is the form of implies, if and then. But again, to be able to put it in that form, we have to add the negation. So in order for us to remove the necessary condition here, in order for us to remove these keywords, we have to use if and not and negate the P or even the R as it indicated here. We have to negate it. And we also have to negate the S, which is the second portion. Okay. So is that clear to you or is confusing?
Mm.
A bit confusing?
So far, it's clear. Mm.
Okay.
No,
So
so far it's clear.
okay,
Mm.
that's good. So see, I will end up our class here today like that. Um, I will try to provide you
All right.
with exercises. I will try to make it as simple as I can on the first time until we discuss together how it is going to be. Okay. So do you recognize that
Okay.
our next class is not going to be on Wednesday, right? Next Wednesday, we're going to take it on Saturday.
Yeah, I realize.
Okay. Okay, that's good.
Yeah.
Do you have any comments on the class or anything that you would like to see on the next coming classes?
So far I have no comments. I think it's been okay so far.
Okay. So,
Mhm.
okay, we stick to this way, and then every class I will check with you if you need to have a different way of explanation or yeah, things like that. Sorry, we didn't have a chance today to practice exercises, but we will do that from the next time. So typically you don't have a pen, right? So you don't have a stylus pen, right?
Uh, well, not really.
Oh, no problem. It's
Nope.
okay. I will tell you a way that you are able to answer things on the next class. But it's okay. Wait for the next class and we
Okay.
discuss about it. Okay. Anything else you would like to tell me? Javin? Javin? I can't hear you. Javin? Hello, hello. Javin? Javin? Javin?
Sorry, my family came in.
Okay. So no problem. It's okay.
Okay.
So do
All
you
right.
have any comments? Should we close?
Yeah, I think we can stop here.
Okay, no problem. So I will pass
Yeah.
you the exercise on your WhatsApp. Okay.
Sure. All
Okay.
right.
Take care. Bye bye.
Okay. All right. Bye bye. Thank you.